Okay, question 9. Student investigates the extension of pairs of identical springs. Now you've got to read this quite carefully. Which pair will have the same extension as one spring pulled with a force of 5 newtons? So the one that we're trying to match is one spring with 5 newtons on it. So we want to find one of these that will extend by the same amount. Now this is one that actually comes easier if you've had a chance to play with springs or elastic bands at some point in your life. I have, and some of you might have done. If you take an elastic band and kind of put a weight on it or pull it with a certain amount of force, it stretches by a certain amount, okay? And I could perhaps pick something to hang on it and think, or maybe pull it by a certain amount and think, how much does it stretch, okay? And that's my reference, is I think, okay, here's an amount of pull, that's how much it stretches by about sort of, that distance. If I put two together like that and pull with the same force, it's quite a lot harder to pull, okay? I've got 2 elastic bands that I'm going to pull against now. It actually stretches less with the same force. So I'd have to pull harder to make it stretch further. So it's not the first one because actually it doesn't stretch as far. But this one, okay, I've got 2 elastic bands, but if I pull with twice the force, so 10 newtons instead of 5, actually it feels like it might be going the same distance. Okay, that's pulling twice as hard and it's going about the same amount. So let's put that one as a question mark. This one, C, well, we've joined the 2 elastic bands together. Let's see if I can do this. Whoops, nearly. There we go. Join the 2 elastic bands together, one after the other, like that. Okay, if I pull now with the same force that I did before, okay, it stretches quite a lot. Okay, so that's stretching much further than just one on its own, because there's 2 of them that are stretching sort of the same amount each. For the final one, so it's not that one, that's stretching too far, and this final one, if I stretch with even more force, like twice the force, that stretches even further, so it's not that one either. So the one that actually works is this one, so it's B. Okay, number 10, a boy swims in a lake at a depth of 1 metre. What is the change in pressure if he swims at a depth of 2 metres? Now this is one where you have to read very carefully, because your immediate thought is, what's the pressure at a depth of 2 metres? But it is effectively, here's my lake. He started off swimming at 1 metre depth, and he ends up swimming at 2 metres depth. Okay, so we have to find out what's the pressure difference between those 2 heights, or those 2 depths rather, in the water. So he's actually gone down by 1 metre. Now, you need to remember that there is an equation. It's a good idea if you can remember it, but actually the equation is on the sheet. This is somebody's sheet, I don't know whose this was, but they wrote the other equations on here, so ignore those. The one that you need is pressure due to a column of liquid is height of column times density times G. Okay, and the way I remember it is pressure is H, so the height of the column, times rho, which is the density, times G, which is gravity. And they've given you G here, and they've given you density. That gives you a clue that that's the equation they want you to have. So the pressure due to that extra 1 metre of water, okay, because you've gone down by an extra metre, is 1 metre times the density, which is 1,000, times 10. Well, I can pretty much do that in my head, but we'll just do it on the calculator anyway. It looks like 10,000 to me. 1 times 1,000 times 10 equals 10,000. And because I've used the correct units, I've used metres, I've used newtons and kilograms, I've used kilograms and metres cubed, then this is going to be in the correct units, which for pressure is going to be newtons per metre squared, or pascals. Newtons per metre squared is the same as pascals. Okay, so 10,000 is answer C. Now I've done it by looking at the difference between where he was at 1 metre and where he was at 2 metre. You could do it by calculating the pressure at 2 metres and calculating the pressure at 1 metre and subtracting them. If you did that, you would do 2 times 1,000 times 10 for this one, 1 times 1,000 times 10 for this one, and then you subtract them, and this is the answer you would get, because you get 20,000 minus 10,000, and that's, you see, when you subtract them, it would be 10,000. That's why you can just use the pressure difference, is the difference in height times density times gravity. Question 11. A loaded trolley with a mass of 10 kilogram travels 10 meters per second. What happens to the kinetic energy of the trolley if the speed doubles and the mass halves? Okay, so we need our kinetic energy equation. It's not one that they give you, but we can say kinetic energy is half the mass times the speed squared, and I use V to stand for speed just because that's what people do. Okay, now there's a couple of ways of doing this. Let's do the straightforward calculation way. Okay, so let's work out its kinetic energy to start with. Half times the mass, which is 10 kilograms, times its speed, which is 10 squared. Okay, so that's half, so 0.5, times 10 times its speed squared, and that is 500 joules. Okay, let's work it out if its speed doubles. Okay, so that's going to be half times, well, it's going to be, the speed is going to be 20. Okay, squared, and the mass halves, so the mass was 10, so that's 5. Okay, so this is the new situation. It's half times the new mass, which is half of the old mass, 5, times double the speed squared, which is 20 squared. Okay, and let's do that one. It's 0.5 times 5 times 20 squared, which is 1,000 joules. So it's gone up from 500 to 1,000, so it's doubled. So it's answer A. That's a bit laborious in terms of calculations. Let's see if there's a slightly quicker way to do it. Okay, let's look at our equation again. KE equals half mv squared. Okay, so kinetic energy is half mv squared. If I half the mass, then, well, if I half the mass here, that's going to reduce this whole lot by half, so that's going to be kinetic energy times a half. Okay, if I double the speed, then v squared is going to be double squared, which is going to be 4 squared. Sorry, 4 times. V squared is times 4. Okay, and if v squared is times 4, the kinetic energy will be times 4. So kinetic energy times 4. So the overall effect is that because of the mass, the kinetic energy goes down times half. Because of the speed, it multiplies by 4. So the overall effect is times a half times 4, which is times 2. So overall, the kinetic energy doubles. You don't have to do the calculation to find out how much it is. So actually, they could have given you this question without these numbers, and you could still work the answer out. Okay, because you can see what happens to the kinetic energy if you change the mass or if you change the speed.